Start. Hello friend, this is Chandrasekhar and we are going to discuss about this solution for ESE 2018 and I will take this topic design, drawing and safety. So first I will start with the design and then drawing and then safety, and unfortunately this year there are not much questions from the drawing, only one question. That is what, UPSC is very unpredictable. So if one year they will concentrate on one particular topic, then next year they totally change that. Okay, so be aware, you need to well versed with each and every topic. And I am considering set A here. Okay, whatever we are dealing, that is from the set A. Okay, that is the set A. And let's take up the question number 9 in the set A. So consider a trapezoidal lamina ABCD with AB parallel to DC. So I have considered AB and then DC. DC is like this, both are parallel and these are 6 centimeters apart. That means this is a 6 centimeters. The perpendicular distance between AB and DC is a 6 centimeter and AB is 8 centimeter. So this is a 8 centimeter and CD is 12 centimeter. Okay, CD is 12 centimeter and CD extends outward by 1 centimeter from the foot of the perpendicular from B onto DC. So for example, if I draw a perpendicular like this, then DC is extended beyond this perpendicular. Let's say this is a B dash. So this is extended beyond B dash and its value is 1. So if it is 1, then from here to here, that means if I say this as a dash, so from A dash to B dash, this is a 8 and D A dash is then 12 minus 9, that is a 3. So this will become 3. Okay, and the center of gravity of the lamina will be, we need to find out the center of gravity. See, there are always two methods, and please remember my dear friend, this is a this is all about how many questions you solve in the less number of times. Okay, so no one going to ask you to prove your talent. Okay, so don't take up any difficult question and spend most of your time, so that you will be out of the race. So first of all, you need to read carefully all the options. Okay, you read all the options. By knowing the options itself, you can identify how to approach the problem, how to eliminate the problem. If you don't have a chance to eliminate the option, then only we will go for the actual procedure. Okay, so first let's see the options. Along AC at a height of 3 centimeter from the DC. So where is the center of gravity? He is saying that along AC. AC is connecting, the diagonal AC, and this is at a distance of 3 from the DC. So from this side, that is at a 3 centimeter. Okay, and along BD, this time this diagonal B and D, and that is at a distance of 3 again from the DC. So here if you observe, everywhere is mentioning the 3 centimeter from DC, 3 centimeter from the DC. And the third one is along the line joining the midpoint of AB to the midpoint of DC at a height of 2.8 centimeter from DC. Here this value is different from the previous one. What is that value? The distance from the DC. And here the line joining the midpoints of AB. What is the midpoint of AB? 4. And what is the midpoint of DC? That is around 6. It will come like this. So by joining these two, is saying if you take any any point which is at a 2.8 centimeter from the DC, and the fourth one is at the intersection of point AC and DB. Okay, so how to choose this? And what is the main thing, what is the key thing you should know, so that at least you can decide from the given options? The key thing that you should know is the distance of the center of gravity from the side DC. Okay, DC is nothing but a bigger side. So if you know that, then you can find out this. Okay, so that is nothing but a y bar. Okay, if you know the y bar, then at least you can decide, you can eliminate some of the options here. So this is the formula for the center of gravity. Y bar equal to h by 3. This is a 3. H by 3 into b plus 2a divided by b plus a, and where a is the smaller side and b is the larger side, and h is a perpendicular distance between sides a and b. Okay, that means this is the a, 8 equal to a, b equal to 12, and if I substitute these values here in the equation, then we will get to 2.8 centimeters. Okay, so the distance, this is from the big side. Okay, this is from the bigger side, and what is the bigger side here? That is the dc here. Okay, this is from the dc, and by knowing this you can eliminate two options. We can eliminate option a, we can eliminate option b, and only we left with the two options, and let's examine these two. See, by intuition you can say that the intersection point of ac and db may not become the, because this is not so symmetrical, so it may not be the center of gravity. If it is a symmetrically placed, then definitely the intersection point of AC and DB would have been the center of gravity. So how to put this, symmetrically? For example, if AD is if you join the point A to the DC and point B to the DC, then instead of 3 here you may get 2. Generally you will, if you get 2, DA dash is 2 and B dash C is 2, then you left with the 8 in between. That means it's a symmetrically placed. So in that case, the intersection point of AC and DB would have been the center of gravity. So we can remove this also. So what is the left? What we left with? We left with 2.8 centimeter from DC. The second point is correct, and we don't know the line joining. We don't know whether this is on the line joining the midpoint of AB to the midpoint of DC. But anyway, from the elimination we can choose answer as the C here. Okay, that is how you need to choose the answer. And now we will see the actual procedure, how to do this. Okay, now we will see how to do this. See, if I do in the regular procedure, this much of space is taking, and by the time you complete this, then lot of time will be gone. So instead of doing like solving, always remember, my dear friends, here becoming successful in the exam is important. Now we no need to prove our talent in the exam. That is how these exams are modeled. Okay, so never ever don't take up lengthy or difficult problems. Okay, you can take those problems only at the end. Okay, sometimes what happen, you may get in the temptation, that concept and everything, they it's very, they give very easy problems, but they are too lengthy to solve. So in those cases, just simply leave it. Okay, so this is the actual procedure here. So I have considered the origin at the see, I reverted this trapezoid whatever I showed in the previous one. So you can take in the that direction also. If you take in the whatever actual trapezoid I have taken in the previous case, then it would be very easier. But now I want to see in the reverted case, I want to see how it looks like, or how it comes. Okay, so here AB is 8 and DC is 12, and then EC is 1, and so that DF will become 3. Okay, and this is the 6. What is that? AF is 6. Here BE equal to, this is a AF equal to 6, and AB 8, CD 12, and EC 1, DF is a 12 minus 9, then you will get the 3 here, and I have taken origin at the point J, and this is the formula that I am going to use. Okay, x bar equal to, that means if you have a big section, then if you don't know the the exact shape of the section, then we will subdivide that section into noun shapes, and we will find out the center of gravity for each section, each noun section. Then from that we can find out the center of gravity of the cumulative section. So that is what we are trying to do here. Okay, this is the formula that we have already dealt in our video lectures, and this is for the y coordinate. See here, my dear friends, these design problems are mostly easier for the mechanical and civil engineering, but these are relatively very new to the this electrical and electronics background people. Okay, but since this is a relative exam, and if a average fellow in the electrical and electronics couldn't do this type of problem, then it doesn't mean that they is going to lose any marks. Why? Because if average fellow in the other branches, unable to attempt this questions, that means most of the people also fail to attempt these questions. But if you know how to solve these questions, then definitely you will get an edge. So that's why we have explained everything in our video lectures, IES GES video lectures, very briefly, so that it will comes very very handy and easily understandable. Okay, so I divided the structure into A1, where A1 is a triangle AFD. See, this is a A, this is a F and D, and then A2 is a rectangle ABFE. Okay, so that rectangle is this A, B, E, F. Okay, and then one more triangle, triangle BEC. See, BEC. Okay, and then area of the triangle JFD, that is half into base into height. Here base is a D in DF and height is a AF. Okay, that is what I substituted here, and we got the 9. And what is the y dash? Y dash, see, y dash is the center of gravity of that particular portion whichever we have considered in the y direction here. So we know the center of gravity of a right angle triangle, that is h by 3 from the base. See, this is if I consider this as a base. Why? Because this here y is perpendicular to the base df. Okay, so that is h by 3. That means f by fa by 3, and it will be measured from this side. Okay, but we need from the point A, then h minus h by 3, that means 6 minus af by 3, then you will get 4 here. And what is the x bar? That is the center of gravity in x direction. So here the x is perpendicular to the af, then in the triangle afd, af will become the base and df will become the height. So here height by 3, but here height by 3, but this is in the negative direction. Why? Because x is going along AB, but here we are going in the opposite direction like this, so negative, so we got the -1. So my dear friends, very very careful about the negative values. Okay, here negative values, if you overlook these negative positive signs, then you will end up with the wrong answer. And I will take the section ABFE. Here the area is length into breadth, so 8 into 6 equal to 48. And then y dash or y bar is, from the AB half the distance of AF. Okay, so AF by 2, that is 3. And what is the x bar? X bar is half the distance of AB perpendicular to the AF. Okay, then that is 8 by 2, then we will get the 4 here. And again we will take the triangle A3, that is a triangle BEC. So what is the area? Half into base into height. Base is EC here, and then height is BE here. Okay, then if I substitute those values, we will get the 3 here. And what is a y bar? Y bar is again the centroidal distance in the y direction. Here y direction is nothing but perpendicular to the base EC. So that is h by 3 from the base, but we need from the point B, then h minus h by 3, that is this one, h minus h by 3, then we will get the 4. And we need to find out the x value. Okay, x bar. So first we'll find out x from the distance from the point B. Okay, in this direction. Here the base is BE in the triangle, and the perpendicular distance to the BE is EC, and that will become height in this particular case. Okay, that is h by 3, that is nothing but EC by 3. But here the origin is at the point A, so we need to measure from the point A. So AB plus EC by 2. EC by 3. So this is the value and we will get 25 by 3. And sigma A total area, and then here this is the formula x bar equal to x1 bar a1 plus x2 bar a2 plus x3 bar a3 divided by sigma a. Okay, this is the divided by sigma a. If I substitute the values, then we will get 3.46 centimeter from point A. Okay, you need to remember this. And here in the formula, if you observe, this is a negative value. Why we got the negative value? Because here we got the -1. So that's why, my dear friends, you need to be very very careful about the sign convention. Okay, and now let's see for the y dash again and substitute in the equation. So then we will get the value 3.2 centimeters from the 3.2 centimeter from the A, that means from the AB. Okay, this is from the AB. And if it is a 3.2 from the AB, then how much from the DC? That is 6 minus 3.2, that is 2.8. This is a 2.8 centimeter from the DC. Okay, this is the value from here. See, this is what we got in the option 3. And next one is we need to see this point, like what is the midpoint of AB? This is the midpoint of AB. Okay, and what is the midpoint of DC? This is the midpoint. Okay, and these are the points. These are the points. And if you draw a line at a distance of 2.8 from the DC, or 3.2 at a distance of 3.2 parallel to AB, okay, then it is like this. And you know the point of midpoint of DC and midpoint of AB. And if you find out the equation of let's say this is the point E, and this is the point F. If you find out the equation of EF, and if you substitute this equation with this equation EF, then you will get the same point here. Okay, by doing that, so you can choose the option C. That is the procedure. And what's about the option 4? The option 4 is saying that it is the intersection point between the diagonals AC and DB. Okay, then in that case, how to find out AC and DC in that particular case? So in that case, see, let me, so in that case, how to find out? See, I first find out the points for this corner points. So A is 0 0, C is 9 comma 6. Okay, C is here because origin is at the point A, and B is 8 comma 0, D is minus 3 comma 6. First we need to find out the equation of AC and then equation of DB. So what is the equation of AC? Equation of any line is y equal to mx plus c. Mx plus c. What is the m here? M is the slope, and c is the the length made by this particular equation on the axis, either on the x-axis or either on the y-axis here. But here in this particular case, this is making some intersection on the x-axis. Okay, so how to find out so by knowing slope and then intersection on the x-axis, but in this case we don't know, but instead we know the point. So when you don't know the points, then you can write in this format. Okay, this is the basic equation at 10th or intermediate level, so we are not going in detail, but straight away we'll take, that is y minus y1 equal to y2 minus y1 by x2 minus x1. This is the slope here, slope of the line, into x minus x1. Okay, if I substitute point x1 y1 at the A and x2 y2 at the C, then you will get the equation 1 here. Okay, and the same way I will substitute the point D and B in the given equation, this equation, then we will get the equation 2. So by solving these two, equation 1 and 2, you will get these values. So x is 3.6 and y is 2.4, but this is not matching with our x bar and y bar. Okay, that means the intersection point between the two diagonals is not the center of gravity. So that by simply observing the structure also we can directly tell that. Okay.